20.1 Introduction to Circular Motion. Circular motion occurs when a constant force is applied perpendicular to an object's motion. As a result of this perpendicular force, the object moves in a circular path. A projectile is an example of an object traveling with a circular motion. A projectile has horizontal velocity, and the force of gravity acts perpendicular to the velocity. As a result, a circular path is formed. Another example of an object traveling in circular motion is when you have an object that is swinging by a string. The radius of the circular motion is the length of the string. The object has a velocity that's tangential to its motion, and the tension of the string acts perpendicular to that velocity. As a result, the object swings in a circle. Sources of centripetal force. Objects do not exhibit circular motion on their own. Left to its own devices, an object will never travel in a circle. Newton's first law tells us that objects in motion should stay in motion, continuing in the same direction at the same speed. But if there's a force, objects can change direction or change speed. There must be a net force that causes the circular motion in order for an object to change direction. So the net force on an object can cause the centripetal force. So the centripetal force isn't a force itself, it's a force that happens as a result of a net force. For example, the gravitational force can cause an object to travel in a circle. This is seen with a projectile or with a satellite, which is an object that's traveling in a circular path around a planet or a moon. In this case, centripetal force equals the gravitational force. It could be due to the tension force, which happens when you have an object that's swinging on a string. In this case, the centripetal force is caused by the force of tension, so centripetal force equals force of tension. The force of friction can also cause centripetal motion. For example, a car turning on a road. When this happens, the centripetal force is equal to the force of friction on the car. There are several formulas that we use to describe centripetal motion. The first is the formula for centripetal acceleration. Centripetal acceleration occurs when you have an object that's traveling at a constant speed, which means the speed does not change any time in the circular path, but it's accelerating because we're changing direction. In this case, the centripetal acceleration is equal to v squared over r. AC stands for centripetal acceleration, or the acceleration in the circular path. V is the speed, because that doesn't change as the object travels around the circle. And r is the radius of the circular path. Acceleration is measured in meters per second squared, radius in meters, and speed in meters per second. We can use this centripetal acceleration to generate a formula for centripetal force. F equals ma, this is Newton's second law, therefore the centripetal force equals mv squared over r, which is mass times the centripetal acceleration. The acceleration formula is on your data sheet, but the force formula is not on your data sheet. You're expected to be able to generate this using the acceleration formula and F equals ma. Example. Calculate the centripetal force on a 2.5 kilogram object whirling at 3.5 meters per second in a circle with a radius of 0.8 meters. We use the formula Fc equals mv squared over r. This is 2.5 kilograms times 3.5 squared divided by 0.80. Which gives us a centripetal force equal to 38 newtons. This 38 newtons causes the object to travel in a circle. Often, rotating objects can also be described with the idea of period or frequency instead of speed. The period for an object traveling with circular motion is how long the object takes to go around the circle once. It's really a measurement of time, but it's a very specific time. The symbol we use for period is capital T, not to be confused with small t, which refers to any time. Period is a capital T. The unit of period is the second, just like time. Frequency is the opposite of period. Frequency is how many times the object travels around in 1 second. The symbol we use for frequency is small letter f, and the unit is the hertz, although the hertz is actually just a constructed unit, which is 1 over a second, or seconds to the -1, but because that's awkward to write, we write the unit as the hertz, Hz. Period is calculated by dividing seconds by how many cycles it goes. Frequency is calculated by dividing the number of cycles that it goes by the number of seconds it took to go that many cycles. For example, if you have an object that travels 31 times in 20 seconds, the period is the number of seconds it takes per the number of cycles, so it's 20 over 31. This is 0.65 seconds. The frequency is the number of cycles it goes around divided by the number of seconds it took. This is 31 divided by 20, which is 1.55 hertz. On your data sheet, you'll see two formulas for period and frequency. And it's just inverses of each other. The period is 1 over the frequency, and the frequency is 1 over the period. This allows you to interchange between frequency and period. We can use the concept of period and frequency to look at the idea of centripetal speed. Since speed is distance over time, and distance for an object traveling in a circle is one circumference, one full distance around the circle. And t is the time it takes to travel around the circle, which is just the period of the circular motion. This means we can calculate v by using the formula for circumference, 2 pi r, divided by capital T, which is period. The centripetal speed formula can be applied to find the formula for centripetal acceleration that includes period. We already know the centripetal acceleration equals v squared over r. Since v is 2 pi r over t, this is 2 pi r over t squared divided by r, which is 4 pi squared r squared divided by t squared divided by r. And r appears on the top and the bottom of this equation, so it can be cancelled out once. This gives us the formula AC equals 4 pi squared r over t squared. This is the second formula we can use to calculate centripetal acceleration. We would use this when we're given radius and period, but not the speed. Both of these formulas are found on your data sheet. There's a third formula involving period that is not found on your data sheet. This is the formula for centripetal force. Since F equals ma, the centripetal force equals m 4 pi r squared r over t squared. So we have a formula for force, which is m4 pi squared r over t squared. And this is not on your data sheet. So let's look at where these formulas appear on your data sheet. These formulas are found in the kinematics section, where you find the centripetal speed formula and the two formulas for centripetal acceleration.